Welcome to Learn to Build and Build to Learn AWS IoT series. So far, we have installed Thonny IDE, we have flashed Micropython firmware on ESP32 dev kit, and we are able to connect to this module from Thonny IDE. So before we start doing something on this IDE, let me show you two web pages I think that we should keep in our bookmark. So first one is docs.micropython. This is very important because it contains all the documentation related to Micropython and ESP32. And this quick reference for ESP32, this will give you a very comprehensive overview on what are the things we can do with ESP32 module with sample example code. And this is very useful and handy when we will write our code in Thonny IDE. And another thing, if we go to Micropython libraries link, here we will find different types of library. For example, Python standard libraries, which are microified to fit into this Micropython. And there will be libraries specific to Micropython. Also, there will be specific to different port to expose hardware functionality unique to that particular platform. And if you scroll down a little bit, you'll find some libraries which are very specific to that module. For example, ESP32, you'll find these are the functionalities. If you click any of these, it will take you to the corresponding documentation, and we'll use all this documentation later when we'll write our code. And another thing I would like to share, awesome Micropython website, you'll find a lot of already written libraries which are specific to specific functionalities. For example, for Wi-Fi, you will find all these libraries, and you may find libraries which may not be compatible with ESP32. So it's better to check whether that is compatible with ESP32 or not before you use that one. For example, we'll use Micropython Wi-Fi Manager, this module, though it takes 3-4 lines of code to connect with Wi-Fi. Let me show you here. You need only few lines of code to connect to the Wi-Fi network. But when we deal with actual scenarios or use case, there are a lot of use cases or edge cases are there that you need to handle. And that is where our code becomes very complex and robust to address all those issues or scenarios or use case or edge cases. And that is where this custom libraries comes into picture. So these libraries are already considered all those scenarios. So similar to this Wi-Fi, you will find a lot of different modules like AI, audio, different type of communications. You will find something for IoT. For display, you will find different type of libraries. In our case, we'll use OLED display. So we'll use one of this custom library from here. And so you'll find a lot of different things, but just make sure whatever you will choose that is compatible with ESP32 module. And these modules are mostly hosted in GitHub. For example, Micropython Wi-Fi Manager, this is hosted here. And let me quickly show you how you can import this module in your code. If you go back to Micropython language and implementation, package management, there you'll find the MIP module. And so you can import that module, then you can install mip.install, then package name, and it will try to download the package to the default target directory lib, but which you can change by specifying specific directory path. In case if you want to download this module from GitHub, then you have to use this GitHub : this prefix, then the path, and it will download that module from GitHub, and it will install in lib directory by default, but you can change it if you want using this target option. Let's go back to Thonny IDE. In the cell, we can see REPL command prompt here. Left side, you will see the top section. It will show that local directory, and below this section will show all the files or directory that is part of your Micropython device. In our case, it is ESP32. And once we flashed Micropython firmware, and this boot.py file is coming from there. This is not something that we wrote. So once you click any file, it will open in this code editor. So let's try this one. So you can see this is the code, but all these are right now commented. And I would like to mention one thing here, that there are two specific files for a specific purpose. One is like boot.py. This script gets executed when ESP32 board boots up, and we should try not to write much code here. For our program code, we'll use main.py, which gets executed once that ESP32 boots up. And the reason of not writing much code in boot.py is that if we introduce any issue, the board will not boot up. And here you see there are few lines of code which are commented. So this is basically to enable last two lines, import WebREPL, WebREPL.start. This basically enable this board. Last two line, import WebREPL and WebREPL.start, helps to enable WebREPL for this device. So once you are connected to Wi-Fi, you can connect to this board using browser. So that's why it is WebREPL, and we'll check this later after some time. Now let's write our first lines of code, which is hello world, by convention in programming world. So let's type print hello world. Now let's save this line of code. Click save, and it will give you option where to save to, this computer or Micropython device. Let's select Micropython device and provide a name, hello world.py. This file is saved. You can see the advantage of using this Thonny IDE. Everything is integrated here. We can write code, we can upload the code, and we can execute the code also. So let's try to execute this file. So if you click run the current script, you can see hello world. And let's introduce some mistake. So let's say some wrong name and try to run the script. And we can see the error message in the console, and it says name error, name print1 is not defined. If you click, it will take you to the line where this issue is. So you can see that using this Thonny IDE, we can connect to ESP32 module. We can write code in this code editor. We can upload the code to the device, and we can run the code. We can debug the code. So everything we can do within this Thonny IDE. So that's why it's very convenient to use. And let me share few other comments that we may use during our hands-on practice. One is like stop or restart backend. In our case, backend is Micropython ESP32. So if you click this one, you can see there is soft reboot happened, and that thing you can do programmatically also, but that is what is integrated here. You can make use of it. And there is another option, interrupt execution. So let's say something is going on or running in your ESP32, you want to interrupt. So you can interrupt execution using Control-C or by clicking this one. There is send end of file or soft reboot, that also you can do here. And disconnect, as it says, if you click it, it will disconnect your Micropython device. And if you want to reconnect, just go back there, stop and restart backend, and you are connected again. So now let's talk about these two special files. One is boot.py and main.py. As mentioned, like boot.py gets executed every time the module boots up. So most likely we will not do anything here other than enabling the WebREPL if we want to connect it through browser. Otherwise, we can leave it as it is during our hands-on practice. Create a new file named main.py. Okay. So whatever we'll write within this main.py, that will get executed once boot.py execution is finished. To confirm, let's write one print statement. Print main is called, save, and you see it's uploaded here. Let's copy this and go back to boot.py and add this line. Boot.py is called. Save, it's uploaded. Now, if you go to run and do a soft reboot, or alternatively, if you just press Ctrl D and it will do soft reboot, and we will see first boot.py is called this statement, then main.py. So let's click Ctrl D to soft reboot. And sure enough, we can see that boot.py is called, then main is called. Before I wrap up this video, let me quickly show you one setting that I found very useful, which is shell. So maximum number of lines to keep. So I generally keep it maximum so that I do not lose anything in this console log. If you feel the same way, you can increase this, and I personally found it very handy in some cases. Let's click OK. In case if you do not like this shell, you have option to open external shells by clicking tools, then open system shell, hit enter to get the prompt, and if you type help function, you will get exact same response that we got in Thonny IDE shell. Control T, and to connect it again from Thonny IDE, let's go to run, restart the backend, and we are connected again. That's all for this video. In the next one, we will explore how to connect to this module to Wi-Fi network. And once we are connected to internet, we have endless option to do things with this ESP32 module. Thanks for watching. See you in the next one.